Okay, so we've talked about aligning data before. We've done it with linear models, so we've aligned their years, so it makes it more simpler to find the coefficients. 2005, we went to 0, and things like that. We've also aligned inputs on exponential models, and those were usually to avoid round-off error. But we didn't always do a lot of the exponential rounding as much as we did the linear rounding. And then now, guess what? We get to do rounding again with the log models. Now, one reason is because all input data has to be positive. So if we start off and we have some negative values over here, and then all of a sudden some positives over here, what we're gonna have to do is we're gonna have to shift everything until all of them are positive. Now also because the log function increases or decreases without bound as the input approaches 0 from the right, basically, as we get closer to here, it goes either down or up to closer to infinity, positive or negative. We can align data to get better or worse fitting models. And so that's going to be kind of the key that we'll be using here in this next example to get a better fitting model. And so the model here is going to be as follows. So the data set below can be modeled using a logarithmic function, interchange the points for input and output on the given data table, and write models for the inverted data. And then before fitting the model, align by subtracting 2 weeks. All right, so if we subtract by 2 weeks, that means our points are going to be 1, and then 3, and then 5, and then 7, and then 9. So that's what we're going to actually type in. We'll keep our grams, and I'm going to keep it this way because what I'm going to do is I'm going to first find a logarithmic function, and then I'm going to find a model that's for the inverted data, basically the inverse. So I'm going to do both. And let's go over here. And again, to save time, I've already input the data, so we don't have to worry about spending time doing that. So what we can do is we can first get our log data. Well, now we remember we have to have L1, L2, so we better go in and get that and do that correctly. And then we can go down, and this is going to be our actual function, logarithmic based for this model. So let's go write that one down first. So our log model, we'll put in number 1, and we'll say it's W of A, and that's equal to, and it was 11.298 plus 7.372 ln of A, and that's grams, and that's going to be for a mouse aged, and it's going to be from 3 weeks to 11 weeks. All right. Now, that's the model. Now, whenever we actually do anything and plug in something, we have to think about that. So let's say, it doesn't have it here, but let's say we want to say, what is W of 4? We actually want, age 4. So we're looking and the age here. Well, so we plug in W4, and what do we get? 11.29, can't write. Let's start over. 11.298 plus 7.372 ln of 4, and that's going to be in grams. All right, so let's go and type that in. So let's clear that off, and so we have our 11.298 plus 7 point, and it was 372, then ln of 4. Okay, so we get 21.518. All right, 21.518 grams. All right, now does that make sense? Well, 4 would be right here, and 21, well, that doesn't really match up. Now this is where you have to remember, when we made the model, we subtracted 2. And so if we want the actual age 4, what we have to plug in is that value there, which is 2. And so this one is not the right one. So you have to be careful on what you plug in. And it's always good to check your table to see if the number aligns within that number, and it doesn't. And so then you can say, oh yeah, it should be really -2. So it's got W2. It's 11.298 plus 7.372 ln of 2 grams now. And so now if we go back over here, second enter arrow back, go to oops, not 42, 2, we get 16.408. And so does that fit more here? Well, that's 2, which is actually 4, and that's 16. That's between those two. That one makes a lot more sense. And if we round it to the same numbers here, that's going to be, again, it's probably, I would say it's going to be roughly 16 grams. Okay. Now, if we do the inverted model now, well, that means we have to swap these around. And remember, what is the inverse of a logarithm? Well, the inverse of a logarithm is going to be the exponent, because if you think about, if you have e to something, you have to take the ln of it. And if you have the ln of something, you have to take the e to it. And so what we're going to do now is we're going to come back over here and do a calc, and we're going to do 0, which is exponent. But now we have to swap our numbers because we're inverting those. So that's going to be oops, not L1. It's going to be L2. Okay, well, let's clear that and say L2. This is going to be L1. And now this is going to be our inverted, or our inverse of the function. And so if we write that one down, 209, 1.144. All right, let's go over here. This is going to be now, and what we have is, let's see, maybe A of W now, okay, because now we're coming up with age for the weight we plug in. And so that was the 0.219, and then we had the 1.144 to the W, and that's going to be plus 2 weeks. So that's the model we plug in for the weight. But then we have to remember, because we subtracted off those 2 weeks to get the alignment, we have to add the 2 weeks back actually in our final model. Because if we said, okay, what is A of W for, maybe 25, let's go do that. Let's see if we can remember. Let me write that down again. Okay. Let's say we wanted 25. So we have the 0.219 and then parenthesis 1.144 and then to the 25, and we get 6.325. All right. So if we have A of 25, that's equal to 6.25, and that's weeks, and 25 should be somewhere between 7 and 9. And so that's why we have plus 2 weeks. Okay, so that's going to give us 8.25 weeks, and that does fit the model then, because we have our 25 here, and that's going to be 8 something here. Okay, and it's closer to the 26 because it's 25 here, and so it's closer to the 9 here, which is 8.25. So that does fit, and if we don't round it, that would be what our value was. If we rounded it to the actual whole number, then it would just be 8 weeks, which that's not going to give us the right value, but that's how we're going to do this. Okay, and so those are ways to think about how you have to go back and forth between a regular model and the inverted model. All right, so let's stop there.